Namaskar, welcome to MEDLEARN. Dental Materials series ma as a हामी elastomeric impression material को बारेमा कुरा गर्दैछौं. So let us begin. Elastomeric impression materials को बारेमा कुरा गर्नु पर्दाखेरि चाहिँ first of all we must know which was the first elastomeric impression material to be introduced in dentistry. So के थियो त भन्दाखेरि those were natural rubbers, also known as vulcanite, because they were converted into rubber from their natural latex state by the process known as vulcanization. So simply, first rubber-based or elastomeric impression material to be discovered was polysulfide, then came the condensation silicone, त्यसपछि आयो polyether, र finally आयो addition silicone. है. So अब हामी elastomeric impression materials को बारेमा कुरा गरिरहेछौं. So what is simply elastomers त भन्दाखेरि these are the soft rubber-like, stronger and stable than hydrocolloid impression materials. हामीले चाहिँ हाम्रो previous भिडियोमा चाहिँ hydrocolloid impression materials को बारेमा कुरा गरेका थियौं. Those were alginate र agar हैन. But then यो जुन elastomers छ नि, they are more stable than hydrocolloid impression materials and they are more accurate as well. According to ADA specification number 19, these are known as the non-aqueous elastomeric dental impression material. So let us go into the chemistry र structure of the elastomeric polymers. So यसको structure चाहिँ कस्तो छ त molecular level मा भनेर भन्नु पर्दाखेरि चाहिँ these contain large molecules with weak interaction between them. They are tied to each other at certain points to form a three-dimensional network. So 3D network जस्तो चाहिँ देखिन्छ. अनि अब stretch गर्दाखेरि चाहिँ rubbers-हरु के हुन्छ त भन्दाखेरि the chains will uncoil अनि जब हामी त्यो stressलाई remove गर्छौं नि they will again snap back into their relaxed entangled state. So यो property of the rubber को जुन elastic property हुन्छ नि त्यसलाई चाहिँ यो कुराले explain गरेको छ. Right? So अर्को property अथवा अर्को point भनेको चाहिँ के छ त भन्दाखेरि these are amorphous polymers existing above their glass transition temperature so that considerable segmental motion is possible. That means it is extremely flexible. We know that rubbers are obviously very flexible material. र त्यो कुरालाई चाहिँ यो point explain गरेको छ. है? It can reversibly extend from 5% to 700% depending upon the specific material. Now we have another term which is polymerization. So polymerization भनेको चाहिँ के हो त भन्दाखेरि it is a chemical reaction where number of smaller units of monomers will join together to form the polymer macromolecules. So polymers हरु बनाउने एउटा process by combination of different smaller units or monomers is known as polymerization. So अब polymer भनेको चाहिँ के रहेछ त? It is a long chain of high molecular weight molecules. So simply these are the definitions of various terms that we might come across. Very simply भन्नुपर्दा elastomers are also known as liquid polymers that can be converted to solid rubber at room temperature. By mixing with the suitable catalyst, they undergo polymerization and then cross-linking by condensation or addition to produce a firm elastic solid. अब यो जुन polymerization reaction को बारेमा हामी कुरा गर्दै छौं नि यो चाहिँ various types को हुन्छ के. So types of polymerization reactions ma it can be a addition polymerization or condensation polymerization or ring opening polymerization. So यसको बारेमा चाहिँ we do not have to go into much detail. यही different types हरु हुन्छ भनेर हामीले चाहिँ बुझे पुग्छ. So अघि हामीले initially चाहिँ glass transition temperature को बारेमा कुरा गरेका थियौं हैन. So glass transition temperature भनेको चाहिँ के हो त भनेर बुझ्नु पर्दाखेरि the glass liquid transition is the reversible transition in amorphous material from a hard and relatively brittle state into a molten or rubbery like state. So this transition, the reversible transition, is called as glass transition temperature. So यो पनि बुझिन्छ. Now moving on to classification of elastomers. So here I have just written elastomers, but remember कि हामी चाहिँ elastomeric impression materials को बारेमा कुरा गर्दै छौं र त्यसलाई चाहिँ मैले elastomers को रूपमा पनि refer गर्न पाएँ है. So according to chemistry, it is divided as or classified into polysulfide, condensation polymerizing silicons, addition polymerizing silicons, then we have polyether. Similarly, according to viscosity, we have ultralight, light, medium, heavy, and putty. Similarly, according to wettability or contact angle, we have the hydrophilic ones and the hydrophobic ones. Hydrophilic having the contact angle 80 to 105 degrees and hydrophobic with the contact angle 40 to 70 degrees. So another important topic we are going to talk about the properties of elastomeric impression material. Right? So first property is dimensional stability. अब डाइमेन्सनल स्टेबिलिटी सिम्पल टर्म्समा के हो त भन्दाखेरि कुनै पनि मटेरियल चाहिँ अब हामीले इम्प्रेसन लियौँ नि त अब इम्प्रेसन लिइसकेपछि चाहिँ सर्टेन टाइम बिङ पछि चाहिँ त्यो इम्प्रेसनमा चाहिँ चेन्जेसहरू आउनु भएन हैन यदि चेन्जेसहरू आएन भने वी क्यान टेल द्याट इट इज अ डाइमेन्सनली स्टेबल मटेरियल सो त्यही कुरा हो है सो यहाँ के भनेको छ त भन्दाखेरि डाइमेन्सनल एक्युरेसी मिन्स द ल्याक अफ डाइमेन्सनल चेन्ज ड्युरिङ क्युरिङ or and shortly after removal from the mouth, but dimensional it's or dimensional stability also means lack of dimensional change over time. So simply definition बुझ्नु पर्दाखेरि चाहिँ dimensional stability means lack of dimensional change over time. So simple terms मा यही definition बुझ्दा हुन्छ कि there is no any dimensional change over time भने त्यसलाई नै भनिन्छ dimensional stability है accuracy is very important when the impression is poured with gentle stone or gypsum यो त हामीलाई थाहा भएकै कुरा भयो हैन material may be accurate but may not be stable or inaccurate but can be stable so यो पनि बुझिन्छ so अब dimensional चेन्जेसहरू आउने चाहिँ डिफरेन्ट सोर्सेसहरू हुन्छ के हाम्रो प्रोसेसिङ गर्दाखेरि अनि अब यो कुरा चाहिँ के सोर्सेसहरू छन् त डाइमेन्सनल चेन्जेस हुनुमा भन्ने बुझ्नु पर्दाखेरि चाहिँ देयर इज पोलिमराइजेसन श्रिङ्केज त्यसैगरी लस अफ कन्डेन्सेसन रिएक्सन बाइ प्रोडक्ट त्यसपछि थर्मल कन्ट्र्याक्सन फ्रम द ओरल टेम्परेचर टु द रुम टेम्परेचर अर्को भनेको एब्जर्प्सन अफ वाटर अर डिसइन्फेक्टेन्ट ओभर अ पिरियड अफ टाइम त्यसै गरी इन्कम्प्लिट रिकभरी अफ डिफर्मेसन बिकज अफ विस्कस बिहेभियर र अर्को भनेको चाहिँ इन्कम्प्लिट रिकभरी बिकज अफ द प्लास्टिक डिफर्मेसन है सो यो चेन्जेसहरूको कारणले गर्दा अथवा यो सोर्सेसहरूले गर्दाखेरि चाहिँ हाम्रो डाइमेन्सनल चेन्जेस आउन सक्छ भन्ने बुझिन्छ नाउ According to ADA specification number 19, at the end of 24 hours, the contraction should not exceed beyond 0.5% for type 1 and 3 and 1% for type 2. So all elastomers change dimensionally over time. So main कुरा चाहिँ के देखियो त भन्दाखेरि सबै इलास्टोमर्सहरुमा चाहिँ certain amount of dimensional instability हुन्छ that means they undergo certain dimensional changes over time but the dimensional stability for the polysulfide and condensation silicon is less as compared to polyether र addition silicon elastomers so that means यो जुन पोलिसल्फाइड र कन्डेन्सेसन सिलिकोनको चाहिँ डाइमेन्सनल स्टेबिलिटी कम छ एज कम्पेयर टु पोलिइथर एन्ड एडिसन सिलिकोन विच मिन्स पोलिइथर र एडिसन सिलिकोन्सको चाहिँ dimensional stability is better. So it's the same thing, right? This is because of the release of byproducts in polysulfide or condensation reaction. So the reason for the less dimensional stability भनेकै byproduct of release ले गर्दा हो जुन चाहिँ polyether र addition silicon मा हुँदैन. So if maximal accuracy is to be maintained with polysulfide and the condensation silicons, the slurry mix for the dental stone should be poured immediately into the impression after the removal from the mouth. So यो कुरा त बुझिन्छ है अब हामीले इम्प्रेसन निकाल्यौं र इम्प्रेसन निकालेको केही समय भित्रमा नै हामीले यदि इम्प्रेसन पोर गर्यौं इम्प्रेसन माथि डेन्टल स्टोन पोर गर्यौं भने चाहिँ डाइमेन्सनल स्टेबिलिटी चाहिँ राम्रो हुन्छ. Then, research has shown that the cast poured in the impression of the addition silicon before 24 hours to 1 week was as accurate as the cast made in the first hour, as there was no effect associated with formation of the hydrogen bubbles. Multiple pouring of impression and removal of cast will not alter the dimensional stability. यो कुरा पनि बुझिन्छ। अर्को भनेको चाहिँ the polyether impression absorbs water and causes simultaneous leaching of water soluble plasticizers. Thus it should be stored in a cool and dry environment. So leaching out of the water soluble plasticizers like prevent गर्नको लागि चाहिँ it has to be stored in a dry and cool environment. यो पनि सक्यो। So first हाम्रो property चाहिँ कुन थियो त dimensional stability जुन चाहिँ हामीले complete गर्यौं। Now let us move into another property which is tear strength. So tear strength मा चाहिँ के छ त भन्दाखेरि tear strength भनेको simply it is the resistance of the elastomers to fracture when subjected to a tensile force acting perpendicular to the surface flow. So हामीले चाहिँ यो जुन elastomers हरुको चाहिँ एउटा resistance capacity हुन्छ रे के that resists the fracture when the tensile force is being acted upon it. Tensile force चाहिँ perpendicularly act हुँदाखेरि जुन resistance चाहिँ provide गर्छ नि त्यसलाई नै भनिन्छ tear strength. So so the tensile force लाई resist गर्ने जुन resistance हुन्छ elastomers को त्यसलाई नै भनिन्छ tear strength. Simply बुझ्नु पर्दा. Then the ranking of the elastomers for the tear strength from the lowest to highest भनेको चाहिँ adhesion silicon, त्यसपछि condensation silicon, त्यसपछि we have polyether र we have polysulfide. So tear strength चाहिँ के influence गर्छ भन्दाखेरि by the consistency and by the manner of removal of the material as well. Increased consistency usually increases the tear strength. So consistency increase गर्यो भने tear strength पनि बढ्ने भयो. Addition of thinning agent to the mix will reduce the tear strength slightly, but increases the flexibility substantially. Quick snap removal of the impression usually increases the tear strength. So quick snap may remove गर्यो भने पनि हाम्रो tear strength चाहिँ बढ्ने नै भयो. Now let's move on to another property which is elastic recovery. So elastic recovery भनेको चाहिँ it is the recovery of the elastic deformation following the strain is less rapid for the polysulfide than for the other three type of elastomeric impression material. So recovery or elastic recovery property of polysulfide चाहिँ अरुको भन्दा better छ. This adhesion silicon impression material exhibits most elastic recovery of the current impression material. So current situation मा हेर्दाखेरि चाहिँ the adhesion silicon has the most elastic recovery भनेर भेटियो. Now we have distortion on removal from the undercut is virtually non-existent because they exhibit lowest permanent distortion. So permanent distortion चाहिँ low भएको हुनाले चाहिँ distortion on removal from the undercut चाहिँ हुँदैन. That's it. So अब हाम्रो अर्को very important topic within this elastomeric impression material भनेको चाहिँ impression technique हो. So impression चाहिँ कसरी लिन्छ त भनेर हामी पढ्नु पर्छ, and this is quite often asked in vivas पनि, so we have to know this. So first let us move on according to the viscosity. So single viscosity छ अनि dual viscosity छ. Dual viscosity मा पनि light body र heavy body use गर्छौं र अर्को भनेको चाहिँ Pottiwas technique भनेर हुन्छ. Based on the number of stages, we have one stage technique and we have two stage technique. So moving on in detail, one by one. So one by one जानु पर्दाखेरि चाहिँ one stage single viscosity technique, also known as the monophase technique. So यसमा चाहिँ we use medium viscosity material only because it is a single viscosity technique हैन. So हामीले एउटै viscosity, that is medium viscosity मात्र use गरिरहेका छौं. So method मा चाहिँ के हुन्छ त भन्दाखेरि the paste is mixed and is used both as a tray material र sealings material. यो tray material र sealings material भनेको चाहिँ के हो भन्दाखेरि simply tray मा हाल्ने material र sealings मा हाल्ने material भनेर बुझ्न सकिन्छ है. So sealings material is injected into the tooth surface and the tray material is seated over it. So सपोज हाम्रो यो चाहिँ टुथ सर्फेस भयो हैन यो टुथ सर्फेसमा चाहिँ हामीले सिरिङ्स मटेरियलबाट यहाँ चाहिँ हाम्रो इम्प्रेसन मटेरियल हाल्छौँ भने यो ट्रेमा चाहिँ हामीले ट्रे मटेरियल अथवा त्यही इम्प्रेसन मटेरियल चाहिँ जुन ट्रेमा हालिन्छ नि त्यसलाई भन्छ ट्रे मटेरियल सो यो ट्रे मटेरियल चाहिँ यसको माथि यहाँ जुन हालेको छ नि यसको माथि चाहिँ हामीले यो ट्रे मटेरियल हाल्छौँ सो द्याट्स द थिङ This technique utilizes the principle of shear thinning. The same material which was ejected under pressure through the syringe tip will exhibit the pseudoplasticity and behaves like a low viscosity. So अब चाहिँ के भयो त भन्दाखेरि हामीले same viscosity भएको material चाहिँ we have used as the tray material as well as the syringe material. अनि अब चाहिँ the same material that was ejected under pressure through the syringe tip will exhibit pseudoplasticity. So your syringe material चाहिँ pseudoplasticity exhibit गर्छ and behaves like the lower viscosity material. So यति नै हामीले बुझ्नुपर्ने हो यो टेक्निकमा चाहिँ. Now we have the another one. अर्कोमा चाहिँ के छ त भन्दाखेरि one stage dual viscosity technique also known as the dual phase technique. यसमा चाहिँ notice that it is dual viscosity भन्नाले हामी दुईटा viscosity युज गर्छौं heavy body र light body. यसको मेथड चाहिँ कस्तो हुन्छ भन्दाखेरि two viscosities are mixed simultaneously on separate pads. Heavy body चाहिँ it is loaded on the tray भने light body चाहिँ it is used as a syringe material. So अब सिरिज मटेरियललाई अघि भने जस्तै टुथ सर्फेसमा हाल्यो र ट्रे मटेरियललाई चाहिँ त्यसको माथि सिट गरिदियो अब बोथ मटेरियल विल सेट टुगेदर टु प्रोड्युस अ सिंगल इम्प्रेसन सो दिस इज इट यो भयो हाम्रो one stage dual viscosity टेक्निक भने अब हामी जाम two stage putty reline or two stage putty wash technique. This is also a very important topic. Commonly asked in Vivas. So viscosity used भनेको चाहिँ putty र light body use गर्छौं with a perforated stock tray. So this is important. We have to use a perforated stock tray. Method चाहिँ के हो त भन्दाखेरि first impression is made with a putty in the stock tray. Putty लाई चाहिँ stock tray मा हालेर हामीले impression लियौं. By putting a non-stick material that creates a space for the light body impression. So अब हामीले फर्स्ट इम्प्रेसन चाहिँ पट्टीलाई ट्रेमा हालेर चाहिँ इम्प्रेसन लियौं हैन तर त्यो सँगसँगै चाहिँ हामीले एउटा नन स्टिक मटेरियल पनि हाल्यौं सो दैट इट क्रिएट्स अ स्पेस फर द लाइट बडी इम्प्रेसन है सो अब लाइट बडी राखेर हामीले फेरि इम्प्रेसन लिनु छ नि त सो त्यसको लागि चाहिँ यो नन स्टिक मटेरियलले स्पेस क्रिएट गरिदियो त्यसपछि के गर्यौं त हामीले लाइट बडी इज मिक्स्ड एन्ड इज applied on the tooth with the help of the syringe हैन then the space अब त्यो गर्नु भन्दा अगाडि चाहिँ के गरिन्छ भन्दाखेरि स्पेस मेन्टेन गर्नको लागि जुन मटेरियल हामी इनिशियली हालेका थियौं नि त्यसलाई चाहिँ रिमुभ गरिसकेपछि चाहिँ अब हामीले त्यो टुथ सर्फेसमा चाहिँ सिरिन्ज मटेरियल हाल्यौं र त्यो पट्टी इम्प्रेसनलाई चाहिँ त्यसको माथि सेट गर्दियौं अथवा त्यसको माथि हाल्यौं सो त्यही भनेको छ त्यो हालेर अनि त्यसपछि सेट हुन्छ देन वी गेट द इम्प्रेसन सो दैट इज इट यो खालको टेक्निकको एडभान्टेज भनेको चाहिँ के हो भन्दाखेरि as putty has already set, the syringe material occupies the space of the material that was used to create the space, so it is not displaced. Instead, an accurate impression is made. So, यो process अथवा यो technique बाट चाहिँ हामीले एउटा accurate impression चाहिँ लिन सक्छौं. Right? So, let's move on to another or final technique, which is one stage putty reline or one stage putty wash technique. So यसमा के viscosity हामी use गर्छौं त भन्दाखेरि we use a putty and then we also use the light body again in a perforated stock tray. है so method कस्तो छ त भन्दाखेरि हामीले putty and light body are dispensed and mixed simultaneously. है then putty is loaded onto the stock tray whereas the light body is injected on the prepared tooth. Tray is taken in the mouth and pressed. अब यस्तो गरिसकेपछि के हुन्छ त भन्दाखेरि heavier putty will force the lighter material into the details. Now, once it is pressed and we leave it for some time, both materials will simultaneously set to produce the impression. सो यो मेथडबाट चाहिँ सेट हुने भयो है। यो मेथड अथवा यो टेक्निकको एडभान्टेज चाहिँ के देखियो त भन्दाखेरि फास्टर टेक्निक भयो होइन, किनभने दुइटैलाई हामीले एकैचोटि डिस्पेन्स गरेर साइमल्टेनियसली मिक्स गरेर युज गरिरहेका छौँ। अर्को डिसएडभान्टेज पनि छ कि यो टेक्निकको। सो यो चाहिँ के हो त भन्दाखेरि द पट्टी कन्सिस्टेन्सी मिक्स माइट डिस्प्लेस द सिलिङ्स मटेरियल, दस प्रपर इम्प्रेसन मे नट बी मेड। सो यो चाहिँ यसको डिसएडभान्टेज भयो है। सो हामीले चाहिँ डिफ्रेन्ट टेक्निक्सहरू पढ्यौँ टु मेक द इम्प्रेसन विथ द इलास्टोमेरिक इम्प्रेसन मटेरियल, र एज अ होल हामीले चाहिँ इलास्टोमेरिक इम्प्रेसन मटेरियलको बारेमा पढ्यौँ। सो द्याट इज इट फर द इलास्टोमेरिक इम्प्रेसन मटेरियल। यदि तपाईँलाई यसको नोट अथवा बेसिक साइन्सको कुनै पनि नोट चाहिएको छ भने तपाईँले हाम्रो टेलिग्राम ग्रुपमा जोइन गर्न सक्नुहुन्छ, जसको लिङ्क चाहिँ तल डिस्क्रिप्सनमा दिएको छ। सो थ्याङ्क यू फर वाचिङ। थ्याङ्क यू।